So my expectations for the World Laureate Association meetings are the same as they were at the first one. This is a forum where young people will get to meet with older scientists and perhaps learn about what makes them tick and be inspired by them. But it also is a means of bringing together scientists around the world. And actually, the bringing together of scientists around the world is something so very important because of the forces that are tending to pull nations apart and looking upon nations as competing with each other. Yes, there's some competition, especially among companies, but in science, it thrives on collaboration. And there is not a zero-sum game, because one scientist does something, another inspires another scientist to do something, and together you co-inspire each other, and science advances much more rapidly. So my attitude about the WLA is that it continued to try to bring together across the world many young scientists in contact with older scientists who have been successful, so they may learn about what they did in order to become successful and what they enjoy about science. So it's these things that are very important. What we can do, or what the WLA can do, is to actually begin to have not only conferences, but research centers. And in these research centers, you can bring together more people. In my opinion and my experience, getting people to be together, not just virtually, but really to be in the same room and doing experiments together, is both exceptionally rewarding and drives the machinery of science. So this is what I would hope that the WLA can further do in the coming years. Okay, I'm in several fields of study at the moment. I do fundamental biology, and I try to push back the frontiers of technology based on physics to invent new ways of measuring things of biological interest. So that's one field of study. Another is I've gotten interested in imaging, not for fundamental biology, but imaging for the sake of medicine. And I began to think about new ways of using what is called ultrasound. And many of you know about ultrasound because when ladies get pregnant, they're not allowed to use x-rays, and they use ultrasound on the mommy's tummy to try to image what the growing baby is doing. Those pictures are not very good, and we're devising ways to make much, much better pictures for medical diagnostics. And in fact, we've discovered that there's a way of doing ultrasound that clearly begin to see differences between normal tissue and tumors. So that's very exciting. What are the breakthroughs? Well, the breakthroughs actually occur by combining developments in different fields. Microwave technology and ultrasound are very closely related, but sometimes people in one field don't actually know what is happening in another field. And so what I do is I actually think about what people have done in other fields, mostly by reinventing what has been done before. With batteries, the reason I'm working on batteries is because we want to transition away from internal combustion engines to making very clean personal transportation, or electric automobiles, for example. And we need better batteries. We need batteries that can charge much faster and are much lighter weight, and also much less costly. And so that's something that is very exciting, and there's a real possibility that the things being done in collaboration with Professor Yitwei at Stanford can lead to better commercial batteries. What are the breakthroughs in this field? Well, there are no breakthroughs. It's really beginning to have different clever inventions to solve the problems that prevent you from using, for example, very inexpensive materials like sulfur in a battery rather than nickel and cobalt. So those are things. The goal was we need a better battery, and you have to overcome the problems that prevent this design of battery from becoming commercial. Finally, pay attention to technology. And as I pay attention to technology, what has happened in technology where you can import that technology and use it in your own science? And not only that, can you invent new technology that can actually help do science? And for the last week or two, I spent a lot of time writing a big proposal to the National Institutes of Health for inventing new technologies. In the past, technologies like optical tweezers for atoms, but also for biomolecules, or doing single molecule work, led to widespread use of these technologies. And similarly, the technologies we're developing today, we hope will be widespread tools that many, many scientists can use. So invent new stuff, and when you invent new ways of measuring things and looking at the world, it's easy to discover new things. Well, my secret is I'm completely undisciplined, and I get very interested in many things in life and many interesting things in science. And in fact, get so easily interested in things that in my beginning when I was a high school student, it often would detract me from actually studying the things I needed to study in order to get really good grades. This continues even today. At age 72, in writing the proposal, I got interested in something. I began to have new ideas. I began to pursue the new ideas, and I wasn't writing the proposal. Some of those ideas went into the proposal, others didn't. But the sheer joy of thinking, oh, that's really neat. Can I actually do something about that? Whether it's in energy, or medical imaging, or fundamental biology, what I found is if you have a certain number of tricks that you know about in, for example, physics, or chemistry, or nanotechnology, or lasers, or any number of technical fields, it's so fun for me to pick and choose from all these ingredients as you're doing some cooking. And the more ingredients you have, and the more adventuresome you are, it turns out you can actually, maybe, not necessary, but you can become a better cook. So the secret is actually concentrate on a few things, but have a wide net of interests so that you know these things exist. And then you can pluck from these things, say, maybe I need something from this field in order to solve a problem in another field, or my problem in this other field. And I try to teach my graduate students and postdocs that trick for the last 40 years, and it seems to actually work for a reasonable fraction of them.